Today, we're going to talk about limits. Do I have your attention? Good. Here's the line y equals x minus 2. Every point on this line has coordinates that make the equation true. Here's 2, 0, 4, 2, and so on. This function is continuous, which means we can put in any x value we want, and it's going to be on this line. Now, let's take a look at this equation. Y equals x squared minus 4 over x minus 2. What happens if we put a 2 in for x? We have 4 minus 4 over 2 minus 2. That's 0 over 0. That's undefined. So what do we do with that? Well, let's see what happens as we get closer and closer. If x is 1.9, y would be 3.9. If x was 1.99, y would be 3.99. You can see that the answer is supposed to be 4. So when x is 2, we can't define our answer, but we know what it's going to be. When this happens, we use the word limit. We'll say the limit of this function as x approaches 2 is equal to 4. Limits are math's way of saying we're going to ignore what happens when we get there and just call this what we know it's going to be. Limits are also useful for problems like this one. What's the value of 1 over infinity? Well, infinity isn't a number so much as an idea. So trying to evaluate this is like saying what's 1 over purple? So instead, let's put an x down there and see what happens as x gets larger and larger. If x was 1,000, our answer would be 0.001. If x was 1,000,000, we'd have an even smaller positive number. We can see that as x grows, 1 over x is going to get closer and closer to 0. So we still can't define 1 over infinity. But we can say that the limit of 1 over x as x approaches infinity is 0. That's all for the day. Till next time.